Good day everyone, welcome back to MedicSpank YouTube channel. Now we are still on the topic rules on balancing redox reaction. Now our last video we talked about how to balance, or we talked about the basic concept of redox reaction, how it involves oxidation and reduction simultaneously occurring at the same time but having inverse effects on the reaction. So if you are yet to see that video, you can go check it out on redox reaction. Now the aim of this video is to tell us how to balance redox reaction. Now we have an example here, and these are the basic rules. These are the basic rules we are going to be using to solve our example. And example 1, we have question 1 here which says balance the equation in acidic medium. Now redox reaction can be in two different medium basically, which can be in acidic medium or basic medium. Now for this example, we'll be taking the example on acidic medium. Now we'll be using our various rules to talk about how to balance this equation. Now as plain as this equation is, it could be very tasking to balance in the case of examination condition when you have less time. So we are going to be breaking into piece by piece now so we can know. Now for our first rule here, it says we should make sure that all elements in the equation are balanced other than the O and H. So we are going to check first the elements are balanced. Now the elements we have here is oxygen, we have manganese and oxygen. That's the basic element that was given in our question. Now we have just one molecule of manganese here. Here too we have one molecule of manganese. So that element is balanced in that reaction. So we are going to go over to rule 2 now. So rule 2 is trying to tell us that for a chemical equation, for a redox reaction to be balanced, there must be equal number of elements in the opposite side. Now for that our equation, we had oxygen on one side with manganese forming a manganese oxide. So on the other side we had just manganese. So to balance that, we have to add water molecule to the part of the reaction that does not have oxygen. So it will conveniently balance the equation of the redox reaction. Now back to our question, we would be adding oxygen, or we'll be adding water molecule to the part of this reaction that does not have oxygen. So the reactant side is obviously the part that has oxygen, while the product side has no oxygen. And to balance that, we'll be adding water molecule. We won't add oxygen directly. According to the rule, we'll be adding water molecule to this reaction. So we're adding H2O. So we have added H2O to the product side of the reaction, and we can see according to this equation we have here, there's oxygen here and there's oxygen here. So the right amount of molecules of oxygen to add to this part of the reaction to balance it, because here we have 4 atoms of oxygen while here we have just 1. So to balance that, add the subscript number here as the mole of water. So we'll come to this side, we'll add 4 over here. We'll be adding 4 here. So it will be like 4 molecules of water. Now if you check, we have 4 atoms of oxygen on this product side, and the reactant side we have 4 atoms of oxygen also. So oxygen is balanced in this redox reaction. So now we'll be moving over to our rule 3. So according to our rule 3 here, it's saying that we should balance the hydrogen atom in the reaction. Remember, we added water molecule to the product side of our reaction here. Over here we added water molecule here, and in that case we were adding hydrogen atom to the product side while there was no hydrogen atom in the reactant side. So what we have to do here is very easy. We just add hydrogen atom to this other part of the reaction. So here we'll be adding plus H. So we're adding hydrogen ion specifically. hydrogen ion. That's what we'll be adding there. Now, after adding your hydrogen atom, or your hydrogen ion rather, to your reactant side, what you have to do is to balance the amount of oxygen of your hydrogen in both your reactant and your product side. So if you check here in your product side, you have 8 atoms of oxygen here, because there's 4 mole here and there's 2, so it is like 4 times 2 give you 8 atoms of hydrogen. So at this point, you just come and add 8 over here. Easy, right? So you just come here, add your 8 atoms. So our number of hydrogen here is balanced, our number of oxygen here is balanced, and the only thing that is not balanced at this point is our charges. So our charge here is not balanced with this part. I will be looking at that in our rule 4. Now rule 4 is saying we should add up charges on each side. We should make them equal by adding enough electron to more positive side. Now we'll go back to our reaction. Now at this point, we'll be bringing down the respective charges of our radicals and ion. So manganese oxide here is carrying a -1 charge. So at this point, we'll bring down our -1 charge, and this is aimed at balancing our charge. Now at this point, we'll be bringing down the charge of this hydrogen ion. Now the hydrogen ion normally is to be carrying a +1 charge, but because of the amount of 8 moles it is carrying, it will now be carrying a +8 charge. So it is like the amount of mole is multiplying the charge of the ion. So here it is carrying a +8 charge, while at the product side of the reaction, which is this part of the reaction, we are having just 2 charge on top of our manganese ion. So it is a +2 charge here. Bring it down according to our rule 4. So here we'll be having a 0 charge. Why are we having is 0 charge? If you can recall the rules of oxidation number in different particles or different atoms or ion, for a compound that has no particular charge, that is not carrying any particular charge, the oxidation number is equal to 0. So this H2O here has a charge of 0. Now the reason we are writing -1 +8 and +2 is because these respective ions or radicals are carrying a charge at the top of the atoms. So moving on, the next thing we are going to do is to add the charges of the respective 2 sides of the reaction. Now we are going to be adding the reactant side first. So at this reactant side, we have a -1 charge plus 8 charge. So let's put this in a bracket to show and differentiate our workings. So a -1 plus 8 charge will be equals to a +7 charge. So at this part of the reaction, which is the reactant side, we'll be having a +7 charge, while at our product side we'll be having a +2 charge, because +2 plus 0 is still equal to +2, because the water molecule there has no charge, so it's a 0 charge. So these two will also come down. So at this part of the reaction, we can see that the only thing that is not balanced in this reaction now are the charges. So this is +7 and +2. So the next thing to do is to look for the differences between the higher charge and the lower charge. So the differences between these 2 charges is 5. So if you are saying 7 minus 2, the answer will be 5. Now this will take us to a rule which says we have to add electrons part of the equation with the higher charge. We all know electrons are negatively charged, so this electron here is carrying a minus charge. So adding it to the side with higher charge will simply means we are minusing that number of electrons from the charge. So if we are saying 7 minus 5, it will be 2. That means this part of the equation will also be balanced with this other part of the equation. So we are quickly going to write our final balanced equation for the redox reaction in an acidic medium. So the above are just working on how we arrive at our answer. So then we are going to be indicating where we are to add the -5 charge, or -5 electron charge rather. So here we are still having the same manganese oxide radical. It's 4 here, sorry, adding 4. Then here we'll be adding our 8 hydrogen ion, so at this point we would apply our rule of adding 5 electrons to the side with the higher charge. Now the reactant side is the side with the higher charge, which is +7, and we said electron is carrying a negative charge, so it will be -5 + 7, which is +2, getting it balanced with this side of the reaction. So at this point we'll be adding the 5 electrons. It's 5 electrons at our product side, which is now balanced with our reactant side in terms of moles of each atom, and in terms of charges too. We'll be having the same equation here. So at the product side we are having the same reaction here, which is Mn2+ plus 4 molecules of H2O. Hope you understand. If you have any request for me to solve another example here, please leave it in the comment section, and please like and subscribe. Thank you.